Welcome back to Geometry Classroom. Today we'll talk about angles formed by chords, secants, and tangents to a circle. In this lesson, we have two main objectives. We define angles formed by secants, chords, and tangents, and use theorems about measures of arcs intercepted by these angles. As we know, chords, secant, and tangents are parts of a circle, right? When these parts are intersecting, they form different angles. And in this lesson, we'll talk about how to find these angles formed by chords, secant, and tangents. First possible combination is when a tangent and a chord intersects. And we have a theorem. As we know, as we see here in this picture, this is a tangent, right? And this is a chord. Why is a chord? Because intersect the circle in two different points, and this chord has its endpoints on the circle. Now, what does this theorem state? If a tangent, right, and a chord, right, intersect at a point on a circle, like in this figure, then the measure of each angle, right, formed, which is angle 1, right, and also angle 2 is 1/2 the measure of its intercepted arc, right? Now, as we know, right, because these angles have this, their vertices on the circle, in fact, they are inscribed angles. And we know an inscribed angle, right, the measure of an inscribed angle is 1/2 of its intercepted arc, right? In other words, measure of angle 1 would be 1/2 measure of arc AB, right? Is 1/2 measure of angle 1 is 1/2 of its intercepted arc, which is AB. For angle 2 would be 1/2 of its intercepted arc. Its intercepted arc is ACB or BCA, right? That's the first case. Keep in mind. Let's have two examples, right, with this case. For example, line M, right, is tangent to circle, this circle. Find measure of angle 1. Now, so measure this angle, right, is an inscribed angle, right? According to the theorem, right, the measure of this angle is 1/2 of its intercepted arc, and its intercepted arc is arc RT, right? But arc RT is 150 degrees. So we can say measure of angle 1 is 1/2, means division by 2, right? 150, which is 75 degrees. Another case, it says line M, right, is tangent to the circle. Find measure of arc, RST this time. So we need to find measure of RST. Yeah? Now, we know the measure of angle R, right, is 100 2 degrees. We know the measure of the angle, the inscribed angle, which is 102, right, is half of division by 2, right, half of the intercepted arc. Let's say measure of arc RST. Now, to find measure of RST, right, we have to get rid of 2 in the denominator. How? By using the inverse operation of division, which is multiplication. So, if we multiply by 2 both sides, we'll get 2 times 102 is 204, which is, these 2 cancel, divide out, equals measure of arc RST. Yeah? And this is the answer. Good. Now let's talk about other cases of intersection. Now, we may have interior intersection theorem. What does interior intersection mean? When 2 chords, right, are intersecting inside the circle. As we see here, chords AC and BD intersect at this point, right? And the point of intersection is inside the circle, right? Now, when we have such a case, we have a theorem, right? If 2 chords intersect in the interior of a circle, then the measure of each angle, right, is 1/2 of the sum of the measures of the arcs intercepted by the angle and its vertical angle. In fact, if you look at angle 1, right? Now, angle 1, right? The sides of angle 1 intersect our circle, right? Where? At these 4 points, right? D and C, A and B, right? Now, this angle and its vertical angle intercept the circle at D and C, right? This is the first arc, and A and B, right? In fact, this angle has 2 intercepted arcs, right? Now, the theorem states measure of angle 1, right? Measure of angle 1 is the half of the sum of the intercepted arcs, which is CD plus AB, right? Also, angle 2. Angle 2, right, intercept, let's say, intercept a circle in points AD and BC, right? So, the intercepted arcs for angle 2 are BC and AD, right? So, the measure of this angle would be half of the sum of its intercepted arcs, which are AD and BC. Yeah? So, whenever you have such a case and you have to find the measure of one such angle, you identify the intercepted arcs, you add the measure of these intercepted arcs and divide by 2. Good. Another case is exterior intersection theorem, which means the lines for a tangent and a secant are intersecting outside the circle, right? So we have a few cases for exterior intersections. We may have a tangent and a secant intersecting outside a circle, or two secants intersecting at the exterior of a circle. So when we have such a case, the measure of the angle formed by these lines is half of the difference between the intercepted arcs. And I will show you all these cases with a picture. For example, first case, as I said, when a tangent and a secant, right, are intersecting at a point outside the circle. That's why we call exterior intersection, because the point of intersection is outside the circle. When we have such a case, measure of angle 1, right, our angle, would be the half of the difference of the intercepted arcs. What are the intercepted arcs? The intercepted arcs are AC and, of course, BC. Yes? So this theorem states measure of angle 1 would be 1/2 of measure of arc BC minus measure of arc AC, right? Good. Another case is when two tangents are intersecting at a point outside the circle. So when you have such a case, measure of angle 2, right, would be half of the difference of the intercepted arcs. Again, the intercepted arcs are, first, PQR, right, is one of them. And the other one is PR, right? So again, measure of angle 2 would be half of measure of arc PQR minus measure of arc PR. So we make the difference and divide by 2. Another case is when two secants, right, because these are secants, right, they intersect, there are lines that intersect a circle in two different points or at two different points. Now, when you have such a case, measure of angle 3, again, would be half of the difference of the intercepted arcs. What are the intercepted arcs? Are XY and WZ, right? So we subtract arcs X, Y, and WZ and divide by 2. So don't forget, when the intersection between lines of a circle, right, is exterior, we always subtract the intercepted arcs. If the intersection of the lines of the circle is inside the circle, we add the intercepted arcs and divide by 2. Good. This being said, let's have a few examples with these cases. First, example here, find the value of x. Yeah? In other words, this angle. Now, As we can see, we deal with an interior intersection, right? Because the point of intersection between these chords is inside the circle. Now, because we deal with an interior intersection, we know the measure of this angle would be half of the sum of the intercepted arcs. Now, what are the intercepted arcs? The intercepted arcs are, first, PS, and the other intercepted arc is QR. So, we can say measure of angle X, right, equals half of is division by 2, measure of PS, right, measure of arc PS, plus measure of arc QR. Yeah? So, but measure of angle X equals measure of arc PS is 106 degrees. Measure of arc QR is 174 degrees, right? And we divide by 2 this sum. So, if we add these measures, we're gonna get 280 degrees. And then we divide by 2, and we get 140 degrees. Good? Another case. In this example, we deal with an exterior intersection. Why? Because we have a tangent and a secant that intersect outside the circle, right? And we need to find the value of x. X, in this case, is an arc, is not an angle, because the angle is 72. So, this is our x, right? Let's make it larger. Now, because the intersection is outside, right, the measure of the given angle would be half of the difference of the intercepted arcs. And the intercepted arcs are x, the small arc, and the other intercepted arc is this one, which is 200 degrees. Now, we apply the formula for exterior intersection. So we know the angle, the measure of the angle, which is 72, right, is half, means division by 2, the difference of the intercepted arcs. We start with the larger arc, which is 200, right? 200. Minus the small arc, which is x, right? So we have an equation. We have to solve for x. Remember, we have to get rid of 2 first. We get rid of 2 by multiplying by 2 both sides. So 2 times 72 equals 144. These 2 cancel, divide out. What's left? 200 minus x. Good? Now, first we get rid of 144 by subtracting 144. And we get to the left side 0 equals 200 minus 144 equals 56 degrees minus x. Then we add x on both sides. And we get x equals 56 degrees. Good. That's all we have for today. Next time we talk about intersecting chords and the properties of the segments resulting after their intersection. This is all we have for today. Thank you for watching my video.